Welcome back. In this lesson, we're going to look at the factors that affect the rate of flow in a stream. So the topography of the land is going to make a stream either flow very quickly, such as a waterfall, or rapidly, like a rapid moving stream, or even whitewater rafting, and then slower as the topography changes towards the mouth of the river. So let's look at some of these details. The first concept that I'd like you to look at is whether the water, when it's flowing, flows as a smooth ribbon of water or whether it is rushing. So imagine turning on a faucet, just slightly turning it on, and the water comes out almost like a ribbon. All the water is sticking together. There's no white froth. There's no bubbles. Everything is moving together. That's called laminar flow. There's something very neat about water. Water holds on to itself very, very strongly because of how the molecule works, the physical forces inside the molecule. So water wants to stick to water. That's the reason why water becomes a circle when it falls in a raindrop or when you wax your car. So when water is being sprayed, say out of a water hose, and you put your thumb and you make the water come out in a curve, well, it's laminar flow if you have where it's all parallel together, where we're all moving out together. The opposite of that is turbulent, and turbulent would be anything that looks white water. So if you were to turn on your faucet all the way on and you've got lots of water coming out all at once, instead of coming out as a ribbon, it comes out as a froth, then that's turbulent flow. So what's happening usually with turbulence is that the water is not moving in a single path, but it's moving in cycles and circles, curved passes inside. So you have little eddies inside that water as it's moving. And what happens is that froth is going to lift up sediment from the bottom of the stream and put it into the water. So when water is moving very calmly across it, the sediment basically is still at the bottom of the pond or at the stream. If it is turbulent, then it will carry more load, and that load is the stuff that's dissolved or being carried by the water, the sand, the stones, whatever. So the image on the left is laminar. Even though it is flowing, it doesn't look like it's flowing. It looks like it's still. It almost looks like a pond rather than a stream. But since there's very little eddies or circles of current, instead it's flowing nice straight lines, you have what is called laminar. And then the image on the right would be turbulent flow, where the water is kind of going in all directions at once, and as such, it's got lots of friction. The speed of the stream, it depends on a lot of different things. The first one is the steepness of that stream. That's called gradient. The grade, if you want to think about it, if you've ever gone down a highway and you see the hill that is a 6% grade or a 5% grade, what's happening is it's higher in a certain amount of distance. It drops by a certain amount of height. That's the gradient. Also, whether something is very narrow or wide, the amount of water that it can carry in something narrow, it's going to speed it up. If it's wide, then it can kind of get out of the way of each other, and it's able to go down slower. If it's full of stones or whatever, boulders at the bottom, then the rocks are going to hit against those, and that friction is going to cause turbulence. And then the amount of water that's in it. If it's just rained, you normally have white water even in streams, all of that water is being drained all at once. If you have a steeper grade or a steeper gradient, then you're going to have more energy because essentially you've got a push, a force of gravity that's trying to get that water down as fast and as it can, and so you're going to end up with a quicker stream velocity. The more shallow gradient will be slower. So usually you're going to have a high hill where the rain hits the hill, and then it moves down in the rills and the gullies into the streams, and eventually into the river. And as it's going towards the mouth, it's going to become less and less and less steep. The discharge is the volume of water that's flowing past a certain point in an amount of time. So as you see that, like if it's a narrow stream or a wide stream, depending upon the amount of water in it, will determine that is its discharge. How much water is flowing under the bridge in a certain amount of time. If you were to look at the mouth of the river on one side of a graph and the top of the mountain that the river starts on, the headwaters, on the other side of the graph, and then draw the height as it travels, that is called the longitudinal profile. So if you were to say start on the left, and it would be high in the mountains, and then as it's coming down towards the ocean, it gets lower and lower and lower on the graph. That's the profile, the longitudinal profile. And normally you're going to have it's going to continuously go down from high to low as it goes towards the mouth, where it dumps into a body of water, a lake or a ocean or whatever. The overall shape inside the stream itself is usually going to be concave. So there's going to be the deepest part of the stream will be the center, and then it gets shallower as it gets towards the banks. This is a longitudinal gradient of California. So you have the headwaters of the Kings River, which is at 4 kilometers, and then the mouth of the river, which heads towards the ocean, Pacific Ocean, would be at 0, okay, because that would be sea level, and you'll see the gradient will have steeper sections and shallower sections, and then the speed of the water is based a lot on whether it's steep or shallow. So this is a picture of the lower deltas in the Mississippi, and there's very little gradient here. As it gets down towards Louisiana, the Mississippi River is practically at a 0 gradient. So it's very slow moving, and the water has widened out. The river gets wider and wider. Eventually it even goes over the banks, and you'll end up with several little rivers right at the end of the mouth of the river, and that's called a delta.